Appendix. The appendix is the organ you forget exists until your stomach suddenly chooses violence and sends you to the ER. For years, it was called useless because people can live without it, and surgeons remove it without hesitation. That assumption missed something important. The appendix acts as a backup storage site for healthy gut bacteria. When severe diarrhea or food poisoning flushes bacteria out of the intestines, the appendix protects a reserve by sitting off the main digestive pathway. After the illness passes, those bacteria help repopulate the gut faster. In environments without medical care, this quicker recovery reduces the risk of repeated infection and improves survival after food-related illness. Removing the appendix does not stop digestion, but it removes this bacterial backup, which can slow recovery after major gut infections. The appendix is not useless. It is an emergency support system for when digestion completely fails. Wisdom teeth. Wisdom teeth are the last teeth to arrive, and they immediately start acting like no one asked them to be here. They evolved for early humans with larger jaws who ate raw plants and tough meat that required heavy grinding. Extra molars increase chewing power, helping extract more nutrients and support survival in harsh environments. Modern humans have smaller jaws because diets softened with cooking and food processing. The number of teeth did not decrease at the same pace. As a result, wisdom teeth often lack space to erupt properly, leading to crowding, impaction, and infection. Removing wisdom teeth today usually has little effect on daily function because modern diets no longer require extensive chewing. This does not mean they were pointless. They are an example of evolutionary lag, where a once useful trait becomes inconvenient after lifestyle changes outpace genetic adaptation. Wisdom teeth are not useless by design. They are tools built for a past environment that no longer exists. Tailbone coccyx. The tailbone looks like evolution snapped something off and hoped you'd stop asking questions. It is a small, triangular bone at the base of the spine, and it exists because humans once had tails. When tails disappeared, the bone stayed, but it did not become decorative. The coccyx serves as an anchor point for muscles and ligaments that support sitting, standing, and balance. Several muscles of the pelvic floor attach to the tailbone. These muscles help stabilize the pelvis, control posture, and support organs when you sit or change position. Without this anchor, maintaining upright posture would require more effort and would be less stable. When the tailbone is injured or removed, people often experience pain while sitting, difficulty balancing their weight, and reduced pelvic stability. This shows that even a reduced structure can remain functionally important long after its original purpose changes. The tailbone is not a leftover mistake. It is a repurposed structure that shifted from tail control to structural support, maintaining survival efficiency in an upright walking species. Body hair. Body hair is technically an organ system, which is awkward considering how much effort humans put into removing it. Originally, body hair trapped heat, reduced friction, and helped detect movement on the skin through nerve-connected follicles. This made it easier to sense insects, temperature changes, and environmental threats. As humans developed clothing and fire, thick body hair stopped being necessary. The system scaled down, but it never disappeared. Hair still helps regulate temperature and reduce friction in high movement areas. The muscles attached to hair follicles still activate during cold or stress, triggering goosebumps. The visual effect is minor now, but the nervous system response remains useful. Body hair isn't useless. It's a reduced survival system that still provides sensory and temperature support, even if it no longer does the heavy lifting. If this made you rethink your own body, subscribe. We explain the weird survival stuff your biology never bothered to explain. Goosebumps, erector pili muscles. Goosebumps happen because your body is still prepared for fur, despite clear evidence that this plan did not work out. They are caused by tiny muscles called erector pili that pull hair upright. In furry animals, this traps heat and makes them look larger and more threatening. In early humans, this reflex helped conserve warmth and signal danger. Today, the muscles still respond to cold, fear, or strong emotion, even though the visual effect is mostly pointless. What remains useful is the nervous system response. Goosebumps signal heightened alertness, preparing the body to react quickly to environmental changes. Goosebumps are not a glitch. They are an old survival reflex still wired into the human nervous system. Pinky toe. The pinky toe looks optional until you try walking without it and immediately start negotiating with gravity. It is the smallest toe, which makes it easy to assume it does nothing important. In reality, the pinky toe plays a role in balance and stability, especially during walking, running, and quick changes in direction. As you step forward, weight shifts across the foot from heel to toe. The pinky toe helps stabilize the outer edge of the foot during this motion, preventing the ankle from rolling and keeping the body aligned. This matters most on uneven terrain, which is where humans spent most of their evolutionary history. When the pinky toe is lost or weakened, people often experience reduced balance and increased strain on the ankle and knee. The body compensates, but movement becomes less efficient and more prone to injury. The pinky toe is not decorative. It is a small structural support that contributes to stable, energy-efficient movement. Sinuses. Sinuses are the reason your face feels like it's full of regret every allergy season, even though they're actually doing structural work behind the scenes. Sinuses are air-filled cavities in the skull. Their primary function is to reduce skull weight without reducing strength. A solid skull would be heavier, harder to balance, and more dangerous during impacts. They also help warm and humidify the air you breathe before it reaches the lungs. This protects delicate respiratory tissue, especially in cold or dry environments, which improves survival in variable climates. Sinuses additionally act as shock absorbers. In the event of facial impact, the empty spaces help dissipate force, reducing damage to the brain. Sinuses are not useless. They are lightweight structural engineering that gets blamed for discomfort when modern environments overwhelm a system designed for dirt, fire, and cold air. Vomit reflex. The vomit reflex exists because your body would rather embarrass you in public than let you absorb something that might kill you. This reflex is controlled by the brainstem and is triggered when the body detects toxins, spoiled food, or dangerous chemicals in the stomach or bloodstream. Once activated, it overrides comfort, dignity, and social norms to remove the threat as fast as possible. From a survival standpoint, this speed matters. In early environments, poisoning from plants, bacteria, or contaminated food could be fatal. Rapid expulsion reduced the amount of toxin absorbed and increased the chance of survival. The reflex is intentionally aggressive. It activates before conscious decision-making and does not wait for confirmation. False alarms are acceptable because the cost of reacting too late is much higher than the cost of reacting unnecessarily. The vomit reflex is not a flaw. It is an emergency defense system designed to prioritize survival over comfort. Yawn reflex. Yawning looks pointless, contagious, and socially inconvenient, which makes it the perfect example of a reflex that seems useless until you understand what it's actually doing. Yawns help regulate brain temperature and alertness. When the brain starts to overheat or lose focus, yawning increases blood flow and cools neural tissue, helping restore attention and performance. Yawning is also socially contagious. In group living species, synchronized yawning helped align alertness levels, keeping everyone attentive at the same time. In environments where predators were a real threat, shared alertness improved group survival. This reflex is automatic and difficult to suppress because it is controlled by deep brain structures tied to arousal and awareness, not conscious decision-making. Yawning is not about oxygen, and it is not a glitch. It is a built-in reset mechanism for attention and group coordination that still activates even when the biggest threat in the room is a boring meeting. Palmar grasp reflex. The palmar grasp reflex is why newborns can grab your finger with the strength and determination of someone who does not trust gravity at all. This reflex makes babies automatically close their fingers when their palm is touched. It is controlled by the brainstem and spinal cord, which is why it happens instantly and without learning. In early primates, this grip kept babies attached to their parents' fur during movement, escape, and climbing. Letting go was not an option. A strong automatic grasp directly increased survival. As humans stopped relying on fur carrying, the reflex became less useful. It fades within the first few months as voluntary muscle control develops. The palmar grasp reflex is a short-term survival feature that activates at birth, then quietly exits once it has done its job. If your body feels less broken and more ancient now, subscribe for more survival science hiding in plain sight.